Hello, I'm Tim van Veek. In this video, I'll be looking at how to evolve schemas using C#, moving from simple strings into JSON and then onto Avro, and why you would use Avro. I'll be looking at tooling to generate C# classes from Avro files, and also a bit about how you can ensure that your consumers and your producers don't interfere with each other and everybody plays nicely. Okay, let's start by just pushing a simple string into a Kafka topic. So what we will do is create a new folder, Dotnet producer, and then we'll create a new console application. Start that up in Visual Studio, and we'll do some work from there. Okay, there's some libraries we're going to require, so we'll go into the package manager and add. We're obviously going to need confluent .kafka. And then I'm also going to install a library called faker.net, or faker.data actually, by Jacob Verm. So you won't need this in your application normally, but this will allow us to just create a whole bunch of fake data to push into our topic. Okay, now we have those, we can actually start creating some code. So first of all, for a Kafka producer, you're going to require a configuration. So we'll create a configuration first. We'll call it producer config. We'll import the library for that. And the only thing we really need here at the moment is a bootstrap server, which is going to be where your Kafka cluster and brokers are. That gives us our config for that, and we can now create our producer. Producer builder, and we require the key, which we'll just use as null at the moment as we're starting very simple, and we will be pushing a string. And this takes our config object, and we can build it, and there's our producer. Do a little loop here that'll just keep looping and producing data for us. So we're going to push in users. So let's just push in with a name at the moment. I will use faker for this. Faker.name.firstname. And then we can simply do, let's output that, shall we? So we can see that happening. And we can do a producer and produce. And then the topic we want to produce to. If you haven't created your topic, you may be required to do that beforehand. We're going to use one that explains that we're going to a string topic. This is just a this topic name can be whatever you require it to be. If your Kafka is set to produce or to automatically create its topics, that'll be fine. Otherwise, you'll need to create those beforehand on the Kafka cluster. But I'm going to create mine calling it user string, so that it becomes easier for us to actually maintain the different topics, and I'll explain why in a bit. And then we create a new message. Which is going to have a value of username. And then so this doesn't run away with us, let's do a thread.sleep of 1 second. That's not thread. And we'll have to use our threading library for that. Okay, so we should be able to do a .NET run, probably a .NET build first, just to double check everything's fine. And it's not. Let's rebuild that. Okay, that should be happier. Okay, .NET run this. And you can see it's creating usernames using the faker.data library and pushing those into our topic for us. That's all well and good. Let's create a consumer for that. So directory for a .NET consumer. And this will also be a console application. And again, we will require a confluent library for this. So if we go to our packages and browse and add confluent Kafka again. And then we can get starting with some code. So like our producer, the consumer requires some configuration. So we'll create a consumer configuration object. We'll consumer config. And import that from Kafka. And the consumer has a bit more configuration. So we still have our bootstrap servers. On your ports, we're going to have a group ID because that's only good practice. What we'll do is we'll call it .NET users string, so that if we need to scale up, we can handle that perfectly well. And I'm going to set the auto offset reset to the earliest. So we can always restart that from the beginning if we needed to. Okay, so there's our config object. We can say using and create a consumer. And just like the producer, we have a builder, and our builder is expecting to get back nulls and strings. And it will be built using our consumer configuration. Build that, and now we can subscribe. So we can say consumer dot subscribe, and the topic we're interested in, which in our case is users string. And we can do a little loop that will just go and get the data and spit it out. So if we grab the first object, that should give us an object from the queue, and we can write that out. Let's use a bit of string interpolation and say received user, and then we can grab the result, consumer result dot message, and the value that we got from that message. Build that beautifully, and if we go back to our shell, we can run that. And it should pick up all the ones that we sent with our producer. But it is not. And why is that? That is because this topic doesn't exist, and the producer hadn't flushed the queue of messages that it had yet. So like I said earlier, ensure that you get your topic correct. I did not. Let's run these again. So if we run our producer, we should start seeing them. There you go, coming into our consumer. So we've gone over producing string and pushing it into a topic and retrieving that string from a topic. So we've looked at how to push a string into a topic and then retrieve that from the topic and display those. Maybe we want to start getting a little bit more complex, so there's no use just putting a string in. Maybe you want to start adding to these users. Maybe you need a first name and a surname, maybe some sort of user ID, and those sorts of things. So how would we do that? So the logical way normally that we would normally jump to is, okay, we'll create an object and turn that into JSON, and then push the JSON in. So let's do that. We need to make some small changes and to our producer. We're still going to be pushing in a string because JSON is still a string at the end of the day, but things will change ever so slightly. On our producer side, we will need to create an object, a user object. So let's create a new class. And give it some values. Give it a first name. And a last name. let's give it a GUID as well. Let's get this into a separate file. So we'll give them an ID as well, I think. I'm going to save the GUID, this string as a the GUID as a string actually, just for simplicity at the moment. Okay, so we now have a user object. When we create our new user here, this is still going to be a string because it's just some JSON. And we're going to create a user instead for user equals user. And ID is going to be a GUID dot new GUID dot string. Oops, that's a statement. And a first name is going to be faker dot user dot first name. Faker dot name, sorry, dot first name. And the last name is going to be faker dot name dot last name. That gives us our user. And now we need to just push that into a string on Kafka. I think we'll log out just the first name. I can spell user correctly. And instead of creating just the username here, we can do a JSON serializer. Serialize the user. Just import our library there, and let's send this to a different one, because the problem we're going to have is that our consumer our consumer is going to be looking at using the user string one. They're going to be expecting just a string in that topic, but now they'll be getting some JSON. So we could potentially break our consumers. Our consumers are just expecting a little line that's a first name, and suddenly they're getting things that shouldn't be inside names, like colons and commas and things. So we'll send this to a separate topic. Ensure your topic actually exists on Kafka when you're doing this, or that you can at least have topics created on the fly. So let's build that. Let's build it built successfully, and we can rerun this one. Perfect. So we'll leave that running and go and change our consumer. So our consumer likewise will have a few changes, because now it needs to understand that we're pushing JSON. So I'm going to change the group ID in case I need to scale this up, and where we subscribe to. And when we consume, we get a consumer result, and we can just take a user out of this. Now, I don't have a user object in this project, and keep in mind that your producers and your consumers will be probably on different components, different parts of the network, and they both need to know what a user looks like. And this is something we will cover why this is a problem in a bit. So let's start with JSON serializer. Deserialize. Import this, and we've got to deserialize it into a user object, which we don't actually have yet. But we're going to deserialize our consume result, but the value of that thing. Okay, let's create our user. Now it's pretty easy for us over here because we've got from our producer, this is in the same bit of code, but this may not always be the case. You may have different code bases. You may not be able to access the object that easily. And then it's the whole question of how do you keep these in sync. Oh, that's not a value, that's a message. What value? There you go. Okay, so we'll build this. Of course, we want the user first name, and we will add the surname directly after. Build that, and then go over to where our consumer is and do a .NET run and see what we get on the side. And there's all our users coming in. The other thing you may want to do is in our producer, we may want to actually partition by the ID. So what we can do is we can say, actually, my producer is going to have a string for the key, and the key is going to be the user's ID. There you go. So now we've got them producing with the ID, which means that if we need to scale up, we can determine where that user goes. You can see our consumer has now broken though. That's because it's not expecting a string in that key, and it's all gone very wrong. Can do as well is put our key here. We can get that directly. We have got it in the actual object, but we can also pull it directly from the message itself. Let's rerun this consumer. And there you go, you can see the keys coming in. We're getting the key from the actual Kafka message instead of getting it from our actual object. So we've created a string, produced and then consumed a string. We've created an object, turned it into a JSON string, and produced and then consumed and turned that back into an object. There's a bit of work involved in the code in that we have to maintain the transition into a string and then back out again, which is easy enough for us to do, but isn't something that we should really need to do. Maybe if we could have something do that for us, things would be a little easier and better and out of our hands, so we've got less to break. We also saw that when we change things, we can break our consumers. So maybe we need to look at a way of enforcing that things are perhaps maintained slightly better and people are aware that things are going to be changed, so we don't break our consumers or our producers. So let's see if we can get that happening and if that will benefit us in any way. So what we're going to do is we're going to create an Avro schema. And Avro will allow us to ensure that everyone's fully aware of any changes that we're making and sort of enable an oversight into what's happening and when it happens, and controls when changes can be made. So this will also give us the ability to keep the schema separate from our actual application, so that you have some oversight and people can check and be aware of what version they're on, and give us a bit of versioning as well. So to do this, what we'll do is I will create a new project. And this will be just a class, actually. In fact, it's barely a class. Let's show you how this works. So here's our schema project we've just created. It doesn't actually have a class, so we'll delete this class, and the class will be created for us. We're going to have to update our project file, and we're also going to add some bits in. So we're going to need the Apache Avro library. So let's get that. Install that. And then there's some bits and pieces we need for this. Let's copy these in and we'll go through some of these. So we're going to give it a version, and that's because we're going to package it as a NuGet package for our consumer and our producer to use. Because that way we can package it, we can stick it onto a registry, onto a NuGet package registry, and that'll help us give a bit more control over who's using what and when they're using it. Give it some little tags, and I'm going to generate a package on build. Now, there's plenty of stuff out there about Avro and how Avro works, so I won't go into Avro itself. But I will show you how I would use it. I'm going to copy and paste an Avro file in here. See, do it have Avro as a thing? No, it doesn't. So we'll just create a text file and rename it. And we'll call it what the object's going to be. It's going to be our user object. And that should do it. So we have the Avro package and we have the object. So our object has got a bit of namespace so that we can access it correctly. Obviously, it's a record. It's the user record. And then it has two fields. And that is it at the moment. Let's create a, well, we'll leave the GUID off at the moment. And let's show you what happens when we build this. The tooling you use to get a class out of Avro is called Avro Schema. So let's schema evaluation. Let's build this. So we use Avro Schema to create our classes, and you just literally hand in the Avro file and it will generate classes out for you. So you can see that we've run the tool with this file and it creates for us a perfectly good class with our usernames, our first names and our last names in them. So let's do a .NET build. And that should build that for us, and because we have that package on build, it creates a nice NuGet package for us. Which means I could then push that to our repository like such. Now I have a local repository running Baguette, which is a NuGet package repository. So I'll push it to that. And then the name of our file, which is going to be living over here. So that's in bin release, and our package has been pushed. So we have a NuGet package now. We can change our producer until it actually, I'm not going to use these strings anymore. I want to use Avro, please, for that. And we're going to need to add some more libraries for that. We can do that. We're also going to need the schema registry. So when you use Avro, Kafka maintains a registry of all the schemas being used, and your producer pushes that through. And the reason you want, another one of the reasons you want to use Avro is that when you're pushing JSON, you're having to actually send all the field names as well, and that's inefficient because quite often your field names might be a long field name for a Boolean value, and pushing around field names is inefficient, and storing all them is inefficient. Whereas if you use schema registry and Avro, it will store the schema for you, but only pushes the values out. And that's much more efficient. But it does mean we have to have a schema registry. That's fine though. Here's confluent.schema. Let's see, we will need that one. And we're going to need that for our consumers and our producers. And then we require Avro as well. We also now will need to be able to use our object. So here's our Avro class we've created. We'll need those for our consumers and our producers as well, so that they can access them and they know what they're doing. Okay, so in our producer, we need to make some small changes. When we create our producer, well, there's a few things that changes, aren't there? This is going to use a user. This user object will go. We don't need one of those anymore, because we now get it from VW Avro objects. And don't forget we don't have an ID in that, and it's lowercase. But other than that, it's not much different, to be fair. It's just the way that Avro names things. Okay, then we need to set up our schema registry. So let's set up a configuration object for that first. Schema registry config. Schema. And that takes a URL, which also is going to be on my local machine. And runs on port 8081. We create our schema registry object. And the other nice thing about the way Kafka does this is that it will cache your schemas. So it'll keep a local copy of the schema, so it doesn't have to go and keep getting it from the schema registry. So we'll create a cached schema registry client, which takes in a schema registry config. That's a new one of those, obviously. We can now say with the producer, before you build this, I want to use a value serializer. So I want you to serialize this data before you send it on the wire, and use a new Avro serializer. To serialize a user, please, and take in the schema registry to do that. Okay, so now our producer produces using that serializer. won't have an ID for our key at the moment. We can look at that doing that later. So this will be null again. And it's obviously not a string, it is a user. And we don't need to serialize this anymore because that is now handled directly by our Avro serializing system. Okay, so let's not produce this to users JSON, let's produce this to users Avro. Because again, we don't want to clash and break our consumers. Let's build that, make sure that it's all happy. Go back from here and go into our, oh, we actually have one running, don't we? So let's break that. Of course, that's not wanting to build because other things are using it. There you go. If we run this now, let's finish building. Oh, it's trying to build consumer as well. That's fine. Let's run this one. Stop this consumer. Oh, what did we run? Ah, it's async. Very well. We can't produce like that because we have to be a bit more efficient. So we can await and produce it async, and we will make our method async. So that has made this async because it is a task. Let's tidy that up slightly. Okay, which is fine because that needs to be more efficient, and making that async in production would be the way to go. And you can see we're creating our users. So that's easy enough. We can now create our users, and we have a object to put them in. Let's update our consumer. So in our consumer, our user object can go. And like the work we did in the producer, we'll change that to a group ID, and we'll subscribe to the Avro topic instead. Now, our consumer will be slightly different as well. So we're going to need to tell it about the schema. So our schema registry config is going to be a new schema registry config object. And that again has a URL, which is my local host on port 8081. And then we can say using our schema registry, using that as a new cached client with the schema registry config in that. And this whole thing will be using that. When we create our consumer, again, we don't want to just build directly there. We can say set value deserializer is going to be using a new Avro deserializer. Of type user, and it also has and it uses the schema registry like such. Let's clean this up a little bit. Say why are we moaning? Yes, need to use my object, and we have to do this as sync. Why aren't we happy? Our value deserializer. Oh, that's because we're using it as a string. Okay, of course these are nulls. And this is now a user object. And we're happy again. Okay, so while true, we don't need to deserialize it anymore because we have a deserializer now built into the object, into our consumer. So life should be a little easier. We can literally say the user is this thing. Our field names, don't forget, have changed to be lowercase. And now we should be able to actually just consume directly. So let's do a .NET build on that. And we should be able to run that. And there you go. Oops, let's grab that. Let's get rid of that key, because that isn't a thing anymore. We have to set that to null, haven't we? Okay. So so we've moved to using Avro. We're not pushing our field names across the wire anymore, which is great. That's more efficient. And we've got a way of ensuring that our producers and our consumers get the same object through the schema registry, and also on the code side through your NuGet repository. But let's look at how we would do adding new fields, because the whole point of evolution is you can change your schema as you go. So we will add a new field and see how we can do that. In our schema, what we will do is we will go to our definition and we'll add an email field. Now, if you've got a guild or something in place that is responsible for the shape of your objects, they would normally authorize this and say it's okay and it's the right thing to do. So quite often what you'll do is you'll have a system in place where things will check who's using what schemas and so that things don't get out of hand and just evolve willy-nilly. So you would ensure that everyone's happy that this is the right field to add, and somebody will pass it and say, yes, that's the right thing. And it would be committed into your GitHub repository, and your tooling will do the rest. So we will add in an email field, and it's of type string. And what we'll do is we'll give it a default, because what happens if systems that aren't producing to this, for example, don't have any field for this, what does it need to default to? And we'll default it just to an empty string. You would commit this to your GitHub repository. It would run any test it needs to run, and then it would generate the code, the file. Oh, I have done it. Let's up the version. It would then up the version. Let's go to 1 point. Let's go to version 2. It would then build this release for us, and it would push it to your NuGet repository. So it's there now, and it's ready for people to use. So your producer now can use the new version. You can see this over here, we can upgrade. So I want my producer to use the latest version of this, which is version 2. In my program now, my producer can now produce users with an email. Do we have a, yeah, there you go. And that will produce an email, and literally that's all we need to do. We just upgrade the package and add the new field in, however we determine that field's created. And then we can do a .NET run over here, and we should start producing users with their emails. Now, our consumer hasn't been updated yet. It doesn't know about the email field, so what will it do? You can see what it's actually done is it's still using the old class, but because these messages are being produced with version 2, the schema registry in Kafka is using version 2. So it knows how to deserialize them, but we haven't got the emails coming through. And we shouldn't have, and that's right, because our consumers aren't ready for them yet. So we can happily upgrade our producer and not have to worry about our consumers yet. In our consumer, let's upgrade so we can actually get that email field coming through. You can see that there's an update waiting. It's going, oh, this needs to be upgraded. And you can say, install that for my consumer. So in my consumer now, we don't need that JSON anymore, that's long gone. In our consumer, we can literally just pull in user.email, and we didn't actually have to write any code to do that. None at all. We'll build that, and we'll run that. And there you go, you can see we're getting our emails coming through immediately. What about if we want to remove a field? Can we do that? Let's have a look. So in our schema, in our Avro, remove this field because we don't want it anymore. Somebody says, oh, actually, we're not producing to that field anymore. We'll want to upgrade the build number. The version number. We will regenerate that. We will build that. And we will push that new version. Now, let's have a little look at how we will do this. In our producer no longer reduces to that field. Oops. But our consumer needs to know that that field isn't a thing anymore. So in our consumer, we will update the version. And say this new one doesn't use this anymore. So our consumer knows that this isn't a thing. So we've updated all our consumers so that they're ready. Because the last thing you want to do is remove a field that a consumer is using. That wouldn't be good. So we run our consumer. They've been updated. They no longer have an email field that they need to use. They're fully aware. They're okay. They're happy. And then on our producer, we can say, okay, it's time to upgrade our producer. All our consumers are aware. And now our producer can go, okay, email's not a thing anymore. You can see it's starting to fail over here. We no longer produce to that. And we have updated our producer as well. And that way, nobody's broken anything, and everything's fully in control and smooth. So we've moved from using simple strings to JSON and then onto Avro, which enabled us to use a safer schema evolution, which is smaller on the wire because we're not transmitting the field names anymore, and also significantly easier to code because the system takes care of all the serialization and deserialization for us. If you found this useful, please like and subscribe, and we will see you soon.